Sharing a junction box between a light switch on a 15 amp circuit and a garbage disposal on a 20 amp circuit is permissible, provided each appliance adheres to specific electrical codes and safety measures. Let's explore the underlying principles to understand why this setup is commonly accepted. Firstly, each circuit must have its dedicated breaker within the electrical panel. The 15 amp circuit solely serves the light switch, protecting it from overloads, while the 20 amp circuit exclusively powers the garbage disposal, ensuring it has sufficient amperage to operate without tripping the breaker. Secondly, the National Electrical Code, or NEC, provides guidelines for circuit installation and safety. Article 300.3 C1 addresses situations where multiple circuits reside within the same enclosure, raceway, or cable. The code permits this arrangement, assuming all conductors share the same voltage rating. In residential settings, both 15 amp and 20 amp circuits operate at 120 volts, aligning with this requirement. Thirdly, appropriate wire gauge selection is crucial. For a 15 amp circuit, 14 American wire gauge, or AUG, copper wire is generally acceptable, whereas a 20 amp circuit typically requires 12 AWG copper wire. This ensures each circuit can safely carry its designated amperage without overheating, regardless of their proximity within the junction box. Fourthly, the junction box must be adequately sized to accommodate all wires, connections, and devices. Box fill calculations, as outlined in NEC Article 314.16, dictate the maximum number of conductors permitted within a box based on its volume. Overcrowding can lead to overheating and potential hazards. Fifthly, proper grounding is essential. Each circuit must have a dedicated grounding conductor, typically bare copper or green insulated wire, connected to the grounding busbar within the electrical panel. Grounding provides a low impedance path for fault current, helping to protect against electrical shock. Sixthly, wire connectors and splicing techniques must adhere to industry standards. Using appropriately sized wire nuts or other approved connectors ensures secure and reliable connections, preventing loose wires and potential arcing. Seventhly, consider the load calculations for each circuit. A 15 amp circuit can handle a maximum of 1800 volt amps, calculated by multiplying 15 amps by 120 volts. A 20 amp circuit can handle a maximum of 2400 volt amps. It's important to ensure that the connected loads on each circuit do not exceed these limits. Eighthly, GFCI, or ground fault circuit interrupter, protection may be required for certain circuits, particularly those serving receptacles in kitchens, bathrooms, and outdoor areas. GFCI breakers or receptacles detect ground faults and quickly interrupt the circuit, minimizing the risk of electric shock. Ninthly, FSI, or arc fault circuit interrupter, protection is also becoming increasingly common, especially in new construction. SI breakers detect arc faults, which can be a precursor to electrical fires, and trip the circuit to prevent ignition. Tenthly, always to energize the circuits before working on any electrical wiring. Turn off the corresponding breakers in the electrical panel and verify that the circuits are indeed dead using a non-contact voltage tester. This prevents accidental electrical shock. 11thly, it's a good practice to label the circuits clearly within the electrical panel. This makes it easier to identify and troubleshoot circuits in the future. 12thly, consider the physical layout of the junction box. Arrange the wires neatly and avoid sharp bends or kinks that could damage the insulation. 13thly, when installing devices such as switches and receptacles, ensure they are securely mounted within the junction box and properly connected to the wiring. 14thly, inspect the wiring regularly for any signs of damage, such as cracked insulation or loose connections. Address any issues promptly to prevent further problems. 15thly, if you are unsure about any aspect of electrical wiring, consult with a qualified electrician. Working with electricity can be dangerous, and it's always best to err on the side of caution. 16thly, remember that local electrical codes may vary. Check with your local building department to ensure that your wiring practices comply with all applicable regulations. 17thly, when replacing existing wiring, consider upgrading to larger wire gauges if necessary. This can improve the capacity and safety of your electrical system. 18thly, use only approved electrical components and materials. Avoid using counterfeit or substandard products, as they may not meet safety standards. 19thly, when running new wiring, follow best practices for routing and securing the cables. Use cable staples or clamps to support the cables and prevent them from sagging or rubbing against sharp edges. 20thly, consider the long-term needs of your electrical system. Plan for future expansion and ensure that your wiring is adequate to handle anticipated loads. 21stly, it is important to understand the difference between a circuit and a branch circuit. A circuit is a complete path for electrical current to flow, while a branch circuit is the portion of the wiring that extends from the last overcurrent protective device, such as the circuit breaker, to the outlets. 22ndly, when installing a new branch circuit, it is important to calculate the load that the circuit will be required to carry. This calculation should take into account the wattage of all of the appliances and devices that will be connected to the circuit. 23rdly, the NEC provides tables and formulas for calculating the load on a branch circuit. These tables and formulas can be found in Article 220 of the NEC. 24thly, once you have calculated the load on a branch circuit, you can select the appropriate size wire and overcurrent protective device for the circuit. The NEC also provides tables for selecting the appropriate size wire and overcurrent protective device. These tables can be found in Article 310 of the NEC. 25thly, when installing a new branch circuit, it is important to follow all of the requirements of the NEC. This will help to ensure that the circuit is safe and reliable. 26thly, it is important to understand the difference between a grounding conductor and a grounded conductor. A grounding conductor is a conductor that is used to connect the non-current carrying metal parts of equipment to the earth. A grounded conductor is a conductor that is intentionally connected to the earth. 27thly, the grounding conductor is used to provide a path for fault current to flow back to the source. This helps to protect people from electrical shock. The grounded conductor is used to provide a stable reference point for the electrical system. 28thly, it is important to understand the difference between a single pole switch and a double pole switch. A single pole switch controls one circuit from one location. A double pole switch controls two circuits from one location. 29thly, a single pole switch is typically used to control a light fixture or other small appliance. A double pole switch is typically used to control a large appliance, such as a water heater or a central air conditioner. 30thly, it is important to understand the difference between a single throw switch and a double throw switch. A single throw switch has one set of contacts that can be either open or closed. A double throw switch has two sets of contacts that can be either open or closed. 31stly, a single throw switch is typically used to control a light fixture or other small appliance. A double throw switch is typically used to transfer power from one source to another, such as from a generator to the main electrical system. 32ndly, when working with electrical wiring, it is important to use the proper tools. This includes wire strippers, pliers, screwdrivers, and a voltage tester. 33rdly, wire strippers are used to remove the insulation from wires without damaging the conductors. Pliers are used to grip and bend wires. Screwdrivers are used to tighten and loosen screws. A voltage tester is used to verify that a circuit is de-energized before working on it. 34thly, it is important to wear appropriate safety gear when working with electrical wiring. This includes safety glasses, gloves, and a hard hat. 35thly, safety glasses protect your eyes from flying debris. Gloves protect your hands from electrical shock and cuts. A hard hat protects your head from falling objects. 36thly, never work on electrical wiring when you are wet or standing in water. Water is a good conductor of electricity and it can increase your risk of electrical shock. 37thly, never work on electrical wiring when you are tired or under the influence of drugs or alcohol. Your judgment and coordination may be impaired and you may be more likely to make mistakes. 38thly, if you are not comfortable working on electrical wiring, it is best to hire a qualified electrician. An electrician has the training and experience to safely and properly install and repair electrical wiring. 39thly, when hiring an electrician, be sure to check their credentials and references. You should also ask for a written estimate before work begins. Fourthly, electrical work can be dangerous, so it is important to take precautions to protect yourself and others. By following these safety tips, you can minimize your risk of electrical shock and other injuries. The bottom line is that sharing a junction box between these two circuits is acceptable when done correctly and in compliance with all relevant codes and safety practices. Remember to prioritize safety and consult with a qualified electrician if you have any doubts or concerns.